Hello everyone, and welcome to join today's lecture for Tsinghua University Global Open Course, National Parks and Protected Area of China. And today's topic is nature conservation in agriculture area in China. My name is Yu Le. I'm from Department of Earth and Science. Previously, you've already get familiar with China's national parks, nature reserves, scenic areas, and world heritages. Last week, you also learned nature conservation in wilderness areas. Today, we will learn the relationship between nature conservation with another land use type, which is agriculture. In today's lecture, I will mainly focus on the connection between biodiversity, nature conservation with agriculture. I will start from the introduction and then we'll go to the details. First of all, let's start from the keyword, which is conservation. Nature conservation has goals including conserving habitat, preventing deforestation, stopping species extinction, reducing overfishing, and mitigating climate change. All those goals have been connected with agriculture. Let's take deforestation, for example. As you can see from the picture in the middle, deforestation is the removal of forest from land that is then converted to non-forest use, which is farms, ranges, and urban use. The most concentrated deforestation occurs in tropical deforestation, in tropical rainforests. Nearly all the global deforestation occurs in tropical and subtropical countries. 70% and 80% is driven by conversion of primary forest to agriculture or tree plantation. As shown in this figure, agriculture is the most important driver of deforestation. Here we see the breakdown of tropical deforestation by types of agriculture production: beef, oil seeds, cereals, vegetables, rice, sugar, and other crops, and all transform forest to agriculture area. And this type of land use also destroy the habitat of many species and cause biodiversity loss. Another keyword of this lecture is agriculture area. Agriculture area is land used for cultivation of crops and animal husbandry. The total of area under cropland and the permanent meadows and pastures. The extensive agriculture land use has a major impact on the Earth's environment as it reduces wilderness and threats biodiversity. Therefore, reducing the consumption of resource-intensive products and increasing the productivity of land makes it possible to produce food with much smaller inputs and reducing the impact on the environment. That requires biodiversity-friendly agriculture. Let me ask you a question. What is the percentage of the agriculture area on Earth's land surface? You can use your laptop or mobile phone, search the answer from the internet. I will give you 1 minute. Probably you need some simple calculation. Do you have the answers now? How about this one, 1/3? 2, 3, and a quarter. Okay. 1/5. More. Thank you. So from this figure, we will see the proportion of the global land area today. You all know that 29% of the Earth's surface is land, and in land area, 10% of the world is covered by glaciers, and a further 19% is barren land, which means deserts, dry salt flats, and beaches, and exposed rocks. This leaves what we call habitable land, and half of all habitable land is used for agriculture. So when we multiply 71% by 50%, so which is around 35%, so the answer is 1/3. So this leaves only for the habitable land, this leaves only 37% habitable land for forests, 11% as shrubs and grasslands, 1% as freshwater coverage, and the remaining 1% is built up urban area, which including cities, towns, villages, roads, and other human infrastructures. But for much of the human history, most of the world's land was wilderness. Forest, grass, shrub dominant its landscapes. Only over the last few centuries, driven by the growth in population, the land use has changed dramatically. Wild habitats have been squeezed out by turning it into agricultural land, which caused a dramatic decrease in habitat and a decline in biodiversity. So from this instruction, I hope you've already had realized that connections between agriculture and nature. Then we will move to the second topic, agriculture and biodiversity, to explore the interlinked relationship between each other. Firstly, let's see a summary of some of the main global impacts of food and agriculture. Food accounts for over a quarter of global greenhouse gas emissions. As you already know, that half of the world's habitable land is used for agriculture. 70% of the world's fresh water was used for agriculture, and close to 80% of global ocean and freshwater nutrition-rich pollutions is caused by agriculture. More than 90% of mammal biomass is livestock. Besides, of the 28,000 species evaluated to be threatened with the extinction on the IUCN Red List, agriculture and aquaculture is listed as a threat for 24,000 of them, counts for more than 84%. Then we can conclude that food and agriculture, therefore, lies at the heart of trying to tackle climate change, reducing water stress, pollution, restoring lands back to forests or grasslands, and protecting world's wildlife. In order to balance or coordinate different tasks like agriculture and biodiversity, the United Nations set up 17 Sustainable Development Goals, SDG for short, in 2015. There are 3 goals directly linked to agriculture and biodiversity. Those are Goal 2, Zero Hunger, Goal 14, Life Below Water, Goal 15, Life on Land. With this background, Food and Agriculture Organization of the United Nations, FAO for short, released several reports to assess the state of the world's biodiversity for food and agriculture. Regards to the interlink between agriculture and biodiversity, first of all, I would like to say agriculture needs biodiversity. Just as this figure shows, the benefits of agricultural biodiversity, including offers us diverse and nutritious food, helps plants and animals adapt to climate change, increases the resilience of producers, preserves the health of our ecosystem, and improves the soil fertility and water quality. All those benefits to food production system. Over recent decades, the importance of biodiversity to food security and nutrition has been recognized in international agendas. Starting from 1983, the Commission on Plant Genetic Resources hosted by FAO was established, which highlights the interlinks between agriculture and biodiversity. Over the years, the Commission has overseen global assessment of genetic resources in the crop, livestock, forests, and aquatic sectors and negotiated global plans of action for genetic resources. In 2012, another milestone is the establishment of IPBES, stands for Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Service. It is intended to serve a similar role to the IPCC, which is the Intergovernmental Panel on Climate Change. The IPBES is an intergovernmental organization established to improve the interface between science and policy on issues of biodiversity and ecosystem service. With all those efforts, currently, most countries commit themselves to working to mainstream biodiversity, and bearing in mind that the agriculture and other land use activities heavily depend on biodiversity and its components. The importance of biodiversity for food and agriculture has gradually been recognized. In addition, agricultural biodiversity contributes to multiple sustainability dimensions. For example, resilient livestock, healthy diet and nutrition, biodiversity conservation, sustainable land use, agriculture and forestry, and climate change adaptation. This links to many SDGs like SDGs 1 and 5, SDG 2, 3, 12, and so on. However, agriculture also threats biodiversity. It has been widely recognized as well. For example, as shown in this left figure, the most important threat to bird biodiversity globally are agriculture. In recent decades, expansions and intensifications of agriculture are the most important of many threats affecting threatened bird species. Another example from the right figure, the European White Bird Index showed a 55% decline in common farmland birds between 1980 to 2016, and the downward trend appears to be continuing. In order to limit or reduce the threats of biodiversity of the agriculture on biodiversity, many biodiversity-friendly agriculture practices were encouraged and happened. The figure in the middle is from a FAO report released in 2019, the State of World's Biodiversity for Food Agriculture. The first column listed the biodiversity-friendly management practices and approaches, like landscape management, ecosystem approach to fisheries, restoration, and so on. The first row listed the agriculture production system affected by those practices and approaches. We can read from this figure that more and more biodiversity-friendly agriculture practices were implemented around the world. Let me show you an example of biodiversity-friendly agriculture in China, the rice fish duck system. As one of the outstanding representatives of Chinese traditional mountain agriculture, rice fish duck agro-ecosystem can date back to Eastern Han Dynasty. Within thousands of years, this farming practice has been handed down by Dongzhu people of southwest Guizhou. This agro-ecosystem is the evolving result from co-evolution of human culture and environment. And it has been developed as an extraordinary living model for sustainable use of water and soil resources. A lot of ecological principles are in this system. The ecological cycle greatly increased biodiversity, improved farm ecosystem stability to achieve sustainable development and the use of water. Here I list more examples from the global important agriculture heritage system in China. The rice fish duck agro-ecosystem is one of them, and there are 15 of them in China. All those are very good examples in demonstrate the environment-friendly and biodiversity-friendly sustainable agriculture in China along the history. At the last of this section, I would like to share with you a very recent report with the title Biodiversity Conservation in China, released by the State Council Information Office of China this October. From this title, you can see it is a biodiversity conservation report. The keywords agriculture has been mentioned several times. In Section 2, increasing the efficiency of biodiversity conservation, and Section 4, further global cooperation in biodiversity conservation. This reflects the interlinked relationship between agriculture and biodiversity from another perspective. The first place mentioned is improving safety administration of genetically modified organisms, GMOs. We will discuss this topic at the end of this lecture. The second one is China is leveraging innovative technology in protecting biodiversity and sustainable utilizing bioresources in the fields of agriculture, forestry, fishery, and animal husbandry. The third one is China is progress in the sustainable management of agriculture, forestry, and fishery, and sustainable production and consumption. This paragraphs demonstrate China's efforts and perspectives on agriculture and biodiversity. After we get familiar with interlinked relationship between agriculture and biodiversity, now we will move to another topic on nature conservation in agriculture areas. In this topic, I will introduce you China's practices on nature conservation programs. Many of them were occurred in agriculture area. First of all, let's take a guess again. What is the percentage of agriculture area in China? It may take 2 minutes because that might take some calculations. Because China just released the third land survey report, so you can get this percentage from that report. Do you have the answer now? How about 1/3? 2. And 1/4? 0. So most of you are choosing 1/5? Okay, yeah, I see. The answer is 37%. So actually that is still close to the words, even more than the words. You might be interested in how we know the area and its distribution of the agriculture areas. I will introduce you to the technology, which is the land cover and the land use mapping. The systematic mapping of land cover patterns mostly follow 2 approaches. One is field survey, and another one is using the remote sensing satellite image processing. The second approach is cost efficiency. Employs several image processing techniques to accurately map land cover patterns. In the below, here is a map made by our group with more than 10,000 satellite images with supervised machine learning-based classification at 30-meter resolution. It represents spatial information on different land cover types that on the Earth's surface. For example, like cropland, forests, grasslands, lakes, wetlands. This kind of the map can aid policy development, urban planning, forest, and agriculture monitoring. And the remote sensing actually can provide lots of the monitoring to SDG goals, targets, and different indicators. From this image, you can see that remote sensing can provide information for 14 of the SDG goals. And together with remote sensing and with the social economic data sets together, that can provide lots of the informations. For example, the distribution of the population and also the land cover land use informations. And you can see the land cover land use informations that just cover the 14 of the SDGs and also covers the lots of the 3 SDGs that relate to agriculture and biodiversity. The global land cover land use mapping can be traced back to 1980s. At that time, it's aiming for climate modeling and carbon assessment. But those kind of map was compiled from different digital form of drawing. It's not from a remote sensing based method, though that is the spatial resolution is quite coarse and also have the low map similarity due to differences in source, in methods, and also in classification systems. In 1990s, since the advent of satellite remote sensing, land cover mapping has been one of the most widely studied applications. Global land cover maps were then possibly to be made in a new fashion using identical source at the same time with same classification systems. And then with more and more satellite images that were available, so lots of the products were produced with the better spatial resolutions. So when we have the time series of observations from the satellite, then we can say the world in this way. So here is a time series of the yearly remote sensing images. Can you guess where it is? China? Yes, in China. Which city? Sorry? Okay. Here is the Taihu Lake. So here's Shanghai, and then this is Kunshan. So this city is Suzhou, correct? Thank you. And here's the Yangcheng Lake, have very delicious crab meat. So you can see the very rapid urbanizations. So the urban take place of the cropland. And you can see the land cover land use transitions very quickly. And here's another example in Brazil. So you can see the dynamics of the water and also the urbanizations here and the deforestation replace the forest with cropland. And here's the dynamic of the rivers. With advanced remote sensing image processing techniques, we could produce dynamic land cover map, which include transitions of land cover classes. Here is a dynamic land cover map shows the transitions between cropland, forest, grassland, water, built up, and unused land at annual basis since 1980. With this map, we can see the details of the land cover change, like cropland expansion, afforestation, deforestation, urbanization, and water expansion, and so on. The color bars shows the exact year of change happened. For example, in here, so this is from the Chichihar. You can read from this map, the cropland expansion happened in 2014. This finding can be examined with the high-resolution images or field survey. This kind of a map is very useful to monitor the progress of China's nature conservation. China's nature reserves, or called protected area, were increasing along the years. Since the establishment of the first protected area, the Tsinghua Nature Reserve, China has established a 10,000th protected area, covering around 18% of its land and around 5% of its sea area. Besides of the increase in protected area, China has launched tens of ambitious ecological restoration projects, or called the nature conservation project, across the country to protect its environment and restore the degraded ecosystem. Here are listed 16 major nature conservation programs. For example, Soil and Water Conservation Program, 水土保持工程, Grant for Green Program, 退耕还林工程, and so on. From this figure, we can get more details about investment and area of interventions for these 16 major nature conservation programs. First row is about investment. Second row is about area. From the first row, we can see the investment in the 16 programs from 1978 to 2015 totaled $378 billion, and most of them were invested after 1998. The total annual investment increasing steadily as China's economy grew, from about 3.5 billion in 1998 to 40 billion in 2015. From the second row, we can see in total, those programs addressed a combined area of about 2/3 of China's land area. Does anyone heard about these nature conservation programs? Observed those programs took place in your hometown? I'm sure you are familiar with many of those Chinese names like 三北防护林, 水土保持, 退耕还林, 天然林保护. Have you ever heard about that? Good. Here is the illustrative mapping of China's nature conservation investment against 17 UN SDGs. The depth of the color shading reflects the level of investment for individual program and the total. The numbers are in billion of US dollar. Investment and actions under many programs simultaneously align with multiple SDGs, contributing to 13 of the 17 goals. Most investment contribute to SDG 15, SDG 2, and SDG 1. Owing to this integrated nature, China's sustainability portfolio was characterized by synergies and co-benefits across multiple SDGs. For example, Comprehensive Agriculture Development Program, 农业综合开发工程, directly addressed SDGs 15, 2, and 1, but also had co-benefits for several other SDGs, including SDG 8, which is decent work and economic growth. At present, China's remarkable success in ecological restoration efforts have been extensively recognized by scholars. A NASA study reported that these projects have succeeded in greening up China, contribute 42% of the world's greening trend. To continually practice nature conservation, very recently, in June this year, the General Office of the State Council of China has issued a guideline for afforestation. The guideline highlights 14 measures related to various fields of scientific afforestation, including planning, land arrangement, vegetation restoration, returning farmland to forest and grassland. It urges effort to grow trees and grass following the inherent rules of the ecosystem to improve the stability of the ecosystem and its capacity for self-repair, while coordinating and the protection restoration, and controlling of mountains, rivers, forests, farmland, lakes, grass, and sand. You know that 山水林田湖草沙. The guideline underscores the principle of considering local conditions, land situations, and the capacity of the water resources in vegetation selection. It also urges local authorities to strengthen the management, supervision, and inspection of the land greening activities. From these guidelines, you can see China's continuous determination on nature conservation. Now I'll give you a few examples to demonstrate the links between agricultural protections and conservation. I will first start from one of my studies on oil palm plantation. Oil palm's fruit contain a very popular edible vegetable oil, which is palm oil. The oil is used in food manufacturing, in beauty products, and as biofuel. Palm oil accounted for about 1/3 of global oils produced from oil crops. Palm oil production has increased rapidly over the past 50 years. Oil palm is a very productive crop. As we will see later, it produces 38% of the world's oil, but uses less than 9% of the croplands devoted to oil production. It has therefore been a reasonable choice to use palm oil to meet the rising demand for vegetable oils. However, there are lots of the criticisms for oil palm plantations. Oil palm plantations are one of the major causes of deforestation in tropical countries. Forests converted to oil palm leads to the highest carbon losses and also cause the peatland loss. Protected area is threatened by oil palm plantations, local habitat fragmentation, monoculture, and also biodiversity declines. However, just as I mentioned before, palm oil is quite high yield, and also the profit for planting oil palm is better than the conservations. And there's no quick way to remove or to not using the oil palm. So there's some conflict between the oil palm plantations and biodiversity conservation. So there's a report that gives the suggestion that to mitigate biodiversity loss, effective policies and programs are needed to stop the clearance of native tropical forests for new oil palm plantations. And also better management of oil palm plantation is needed to ensure sustainability and to reduce the impact on the biodiversity. So regards to the management and monitoring, remote sensing can play a very important role. Just as I mentioned that the satellite remote sensing can provide us time series observations. And as this figure shows that the satellite can provide us data that can be traced back to 1970s. So by using those kind of the remote sensing techniques, then we can monitoring the annual changes of oil palms along the years. So when we have the annual changes of the oil palm plantations, we can overlap them on with the protected area. Then we will be able to identify in which places that is overlapped with the that is the protected area, but it's already overlapped with the oil palms, or for which places that is quite close to the oil palms. So those kind of informations can provide us with more or better management for the protected areas. Remote sensing can not only provide us with the observations for the whole plantation, that can also provide us with the individual tree observations. So from this slides, you can see for each individual oil palm trees that can be identified using very high resolution remote sensing images. And health conditions of the individual trees can be labeled and can be learned by machine learning algorithms, then that can be used to identify for each individual trees in the image. And we can also find some gaps. For those gaps, we can regrowth or plant more oil palm trees, which means we can use the plantation areas more wisely, and that will reduce the demand for new oil palms. So this kind of the technology can equals to the better management of oil palm plantations. In this kind of studies, we can have lots of the policy implications. For example, this kind of study that we should raise awareness of the importance of the sustainable oil palm plantation. And at international level, take sustainable oil palm plantation into consideration in post-2020 global biodiversity conservation goals. And also at national level, incorporate sustainable oil palm plantation issue into national biodiversity strategy and action plans. And also we should improve the spatial planning of oil palm plantations. Spatial planning can be carried out at different scales. By using remote sensing, we can have the maps. So those kind of maps can help us to analyze land use, land cover change caused by oil palm plant expansions, and also provide us more information to protect for the protect area planning. And we should also improve the market mechanism and education related to oil palm plantations. To the market mechanism, we should increase the proportion of palm oil certification by the ISPO. ISPO calls the producers to produce the oil with less impact on the carbon and biodiversity. And also, we could strengthen the public environmental education in order to reduce unnecessary demand for the oil palm, for the palm oil and use waste. Followed with this oil palm example, then I will give you a few examples of nature conservation and sustainable agriculture practice in China. I will demonstrate to you a few more cases from the 3 reports. The Big Earth data in support of the Sustainable Development Goals, released by the Big Earth Data Program, Chinese Academy of Sciences. These 3 reports provides more than 60 cases study in total, covering 6 SDG tasks. As I mentioned before, biodiversity, nature conservation, and agriculture are directly related to SDG 2, SDG 14, and SDG 15. Those 3 are all covered in these reports. I have bring one report with both the Chinese version and English version. You can have a look one by one. Yeah, so this is for this year. But due to the time limitation, I will not introduce all the cases, but I will only introduce the 3 cases from the reports. The first case study is about the changes in ecosystems and their quality in China. As mentioned before, since 1998, China has implemented massive ecological protections and restoration programs, such as the Green for Green programs, 退耕还林工程, a conversion of cropland to forest, and wetland and grazing land to grassland, and the nature forest protection project. Therefore, this research assessed the dynamic of China's ecosystem and their quality from 2000 to 2015. Here we can see more details about the results. A total of 50,000 square kilometers of artificial ecosystems. Those artificial ecosystems mainly are agriculture area, were turned into nature ecosystem as forest and shrublands accounting for 52%, grasslands accounting for 40%, and wetland accounting for 8% approximately, which means the 退耕还林, 退耕还草, and the 退耕还湿. In the same period, the overall quality of forest, shrub, and grassland ecosystem in China improved significantly. From the right figure, you can see from 2000 to 2015, the national EQI, short for Environmental Quality Index, the big value means the bad environmental quality, increased 21%. The forest EQI increased 27%. The shrub EQI increased 15%, and the grassland EQI increased 17%. We can conclude that a remarkable result of massive ecological protection and restoration efforts in China since 2000 has shown an overall improvement in terms of ecological restoration, area, and ecosystem quality. The second case study is about the sustainable cropping system in China. Cropping system provides us with food. As the population grows, people apply advanced technology to improve yield, but also cause environmental impacts. Here is the case study of assessing the sustainability of Chinese cropping system. From this case, we can see from the result that for the period of 1987 to 2015, about 1/4 of the croplands in China improved in efficiency in terms of land use, irrigation water consumption, and excess fertilizer application. Since 2000, national average intensity of all three indicators decreased, indicating a more environmentally efficient cropping system in China. The third case is an experiment of efficient ecological agriculture paradigm in the low-yield region along the lower reaches of the Yellow River. This study are under the background that the current agriculture production heavily depends on the use of chemical fertilizers, pesticides, irrigation water, and machinery. All of them have given rise to emerging environmental issues. Here is the experiment of efficient ecological agriculture paradigm, called EEAP for short, in the low middle yield region along the lower reach of the Yellow River. This paradigm has significantly improved economic returns and the sustainability of resources and the environment of the farm. The EEAP consists of a cropping subsystem, a high-value farming subsystem, and an Arabic fermentation subsystem, tested out on a 15-hectare farm. The cropping subsystem produces the grain and provides feed for livestock, and the application of organic fertilizer improves soil sustainability. The high-value farming subsystem provides nutrition-rich and high-value cash crops and livestock products. Meanwhile, it provides the source for organic fertilizer for crops. The fermentation subsystem improves the production efficiency of organic manure fertilizer and the use efficiency of livestock feed using microbe fermentation technologies and equipment. We can see how the farm works from the left figure. Through the EEAP experiment, the right figure shows soil organic matter rose 23%. Consumption of fertilizer, pesticide, and irrigation water dropped by over 10%, 70%, and 1/3, respectively. Compared with the traditional paradigm, the economic returns of the farm increased 62%. These three cases demonstrate China's conservation and sustainable agriculture practices in China. I will give you a very short summary that. Now let's come to the summary of today's lecture. In this lecture, we get familiar with the relationship between agriculture and nature conservation. We know that agriculture area occupied more than 1/3 of the world's and also more than 1/3 of China's land area. And secondly, agriculture activities are a major driver of deforestation, habitat loss, and biodiversity decline. Agriculture and biodiversity are interlinked with each other. Agriculture needs biodiversity. However, agriculture threats biodiversity. That's why people set up more and more protected areas to stop more key biodiversity areas being used by human beings. And they use the many biodiversity-friendly practices. For example, the rice fish duck agro ecosystem in China is one good example of those practices. China conducts many nature conservation programs to balance agriculture and nature conservation. China's nature conservation efforts are still in progress and currently are promoting scientific approach to afforestation. Finally, we learned 4 case studies about the sustainable oil palm plantations, return agriculture area to forest, shrubland, grassland, wetland, and China's sustainable cropping system, and experiment of efficient ecological agriculture paradigm. I hope this lecture gives you a comprehensive picture of the nature conservations in agriculture areas of China. And here's some reading materials. You can find them online. And I will also introduce the discussions of this lecture. The first discussions, there's a debate on the definitions of agriculture, of sustainable agriculture. The goal of sustainable agriculture is to meet society's food and textile needs in the present without compromising the ability of future generations to meet their own needs. So the definition could be characterized by 2 different approaches, eco-centric approach and a technocentric approach. You can read from the screen. The eco-centric approach emphasizes no or low growth levels of human development and focus on the organic and biodynamic farming techniques with the goal of changing consumption pattern and resource allocation and usage. The technocentric approach argues that sustainability can be attained through a variety of strategies. From the view of the state-led modification of the industry system, like conservation-oriented farming system should be implemented. To that argument that biotechnology is the best way to meet the increasing demand for food. Though those 2 definitions have different views on GMO, genetically modified organics. Do you see GMO 转基因 as a sustainable agriculture approach or not, or why? We will discuss it later. And another topic I would like to discuss with you is how can we use oil palm without destroying tropical forest? Just as you see from this figure that oil palm produce lots of the oil, but only take 9% of the area. And from this one, you can also see that the oil palm have very high yield compared to other oil crops. So if to reach demand of people, if we all using the palm oil, that just need such a very few areas to plant palm oil. But if we use others, that will have more land. So how can we what should we do, or what can we do to provide more palm oil without destroying the tropical forest? I just list 2 answers. One is to increase the yield. You know that the yield for oil palm is already very high. but still have some rooms, have some technologies to improve the yield. And another one is, just as I said, that we can have more ISPO, which means we should buy the oil only from the companies that committed to only plant palm oil palms in low biodiversity and low carbon density areas, which should follow the ISPO. So do you have other suggestions or other solutions for those kind of, to have more palm oil but do not destroy the tropical forest? That's all for today's class. Thank you.